Hi folks. So, quick chemistry today. Where we left off was with Niels Bohr and his model of the atom. He got his PhD, quickly went to study with Thomson, and then met Rutherford and started to work with him. Right after Rutherford had done the gold foil experiment and had said that the nucleus is a very tiny center of the atom, but all the vast majority of the matter of the atom is contained in the center, but like only 1/1000th of the atom is this. Most of the atom is empty space, and that there are negatively charged particles that orbit the nucleus. Niels Bohr, the Danish chemist, physicist that got kind of gray at that time in history, he came to work with Rutherford, and he said that electrons, the negative particles that are very, very tiny, they orbit the nucleus. They don't orbit like planets, but they have to stay within certain shells or orbitals. He said that people like Max Planck, this should have been Planck's constant, this is an H, as you know, but people like Max Planck and Albert Einstein, who were applying math to chemistry and physics, math to the atom, they were starting kind of the work that led to the quantum theory, which came after the Bohr model of the atom. He was really interested in what they were doing, and so he said that like light, electrons have a wave-particle duality. They have some features of particles, like they have mass and take up space, and they have some features like waves. And so you can measure frequency and wavelength for the behavior of electrons. And so what Niels Bohr said is that the electron has to stay within the shell unless it absorbs energy, at which point an electron can move to a higher energy shell. If it absorbs more, it can move to another higher energy shell. And if it wants to, so all matter wants to be in the lowest energy state. That's like the goal of all matter. It's called ground state. Ground state, lowest energy state it can be in. So when electrons absorb energy and they move to higher orbitals, they want to get back down to ground state. So they emit. And what they emit is light. And because they can only be in this orbital or this orbital or this orbital, but never in between, it takes a very specific amount of energy to go from this orbital to this orbital to this orbital. So when they emit light, it's a light of one very specific frequency to go from this shell down to this shell. And it's light of another very specific frequency to go from this shell to this shell. And you guys now know how to relate frequency and wavelength. Wavelength is the color of light, and it's inversely related to frequency. And you know that energy is Planck's constant times frequency. So you know that if you have a specific wavelength or color, you'll have a specific frequency. And that frequency is directly proportional to energy, right? So to emit a certain amount of energy to go back toward ground state, the light will be a very specific color. We can actually identify even the makeup of distant stars based on what they're emitting when their electrons get excited and go back to ground state. We can identify elements based on that. And that's called spectroscopy. But you'll see an experiment that's cool with that soon. So electrons have to stay in their orbit. If they absorb energy, they move to a higher orbit, but they can't be in between orbits. Electrons want to always return to ground state, so they emit specific wavelengths of light, specific colors. You'll see that. That's why fireworks have specific colors. Certain elements emit visible spectrum light. Next thing we want to talk about is, let me check my time, hold on.